Okay, in this lesson, one of the things we looked at is what's called change of base. And so we're going to be focusing in on specifically numbers 1, 2, and 3, which is how we do the change of base, and potentially speaking how then we would plug it into our calculator, right? So change of base, the nice thing about change of base is it allows us to take any logarithm, whatever it happened to be, log base 7 of 3, log base 9 of 8, like doesn't matter, but any logarithm we want, and we can rewrite it as a different base. Rather than having base A, we could do base C, which maybe is some other value, base 10, base 12, I don't know, right? But any other logarithm you want. And you would do that by doing that new base. You would put the guts of your original logarithm on the top one, and the base of your original logarithm as the bottom one, okay? The reason this works, I'm going to go ahead and model with our natural log over here by doing something like, we'll call it log base, well actually let's go ahead and just do log base A of B, and I'll go ahead and steal that one. Okay, so log base A of B is some number. I don't know what, but it's some value here. Okay. Using my inverse operations, which we started to discuss in a previous lesson, I know that I can undo this log base A by raising both sides above the A. That would cancel this A log base A, and I'd be left with B equals A to whatever that number was. Okay. Remember, this is all starting with log base A of B is that number. Remember that that's a fact, whatever the value happens to be. Integer, decimal, doesn't matter. When I raise both sides above the A, we end up with B equals A to some number here. Okay? Now, because these two things are equal, what I do to one side, as long as I match that on the other, I will continue to maintain equality. And so again, I could do this with any logarithm that I want, any base that I want. So that could be base 10 or it could be natural log. And so if I did it with the natural log, that would mean putting a natural log in front of both sides. So now we have natural log of B equals the natural log of A to some number. Right? So they're still equal. I did the same thing to both sides. Well, now that this is a logarithm, using my logarithmic properties, I can take this exponent and drop it in front of my function as a coefficient. So number times natural log of A. And then since these two things are being multiplied, I can undo this natural log of A by dividing it to the other side. And in that one step, those now go away, and I'm left with the fact that my number equals the natural log of B over the natural log of A. And that number also equaled log base A of B, which means that log base A of B has to equal the natural log of B over the natural log of A, which is what we have written right here. Okay? And that's how you could prove it for any of them, right? I mean, I chose to put a natural log in front of both. Actually, it was at this step. I chose to put a natural log in front of both this step. I could have put a log base 10 in front of both, and following those same last couple of steps, I'd still get that change of base. Okay? So there's a little mini proof for you there. Okay, so why do we want to do change of base? Well, there's a variety of reasons depending on what field you potentially are going into. But ultimately for us here today, our goal is to make sure we are comfortable with the idea of change of base. It allows us to potentially manipulate our function further. Potentially speaking, if you have a calculator that you aren't comfortable plugging in a logarithm, or you just don't like plugging in the logarithm the way the calculator wants you to. This change of base is a nice tool to have for each of those different contexts. Okay? So we've got here our log base 2 of 5. We're going to go ahead and rewrite this as a change of base and evaluate it. Okay? So it doesn't matter what base you change into. As you can see from my proof, I tend to lean a little bit more myself towards the natural log. Not really for any particular reason, but I do. And so I'm going to rewrite this as a natural log. Well, change of base says if I take the guts of my logarithm and put that on top, I'll be putting the original base on bottom. So in this case, this would be natural log of 5 divided by natural log of 2. And now I can evaluate this. Using any calculator that has a natural log or a log, okay, I could go to my calculator here. Natural log is down above the on button, 2 buttons above, technically speaking. So there's my natural log. And I could do natural log of 5, which is on top. Close that off. Divided by natural log of 2. Close that off, and I'll get 2.3219. Okay? Now, depending on what type of calculator you have, your calculator might actually be able to let you plug in this log base 2 of 5. My 84 does, so if I hit math and then go to log base, it will actually let me plug in log base 2 of 5, which is handy because it allows me to verify that I did do my change of base correctly, and that change of base does work. Because sure enough, whether I do it with the natural log of 5 over natural log of 2, my change of base, or if I do it as the original log base 2 of 5, I get 2.3219 both times. Okay? Okay. So we are also going to do these last two. I would recommend, based off that first one, pause the video, try numbers 2 and or 3 on your own. Restart the video when you are ready so you can either double check your answer or get help if you do get stuck. Okay? So here we go. Log base pi of 32. Okay, doing my change of base, I've got my natural log over my natural log. Guts on top, pi on bottom. Okay, plugging this in, we have natural log of 32 divided by natural log of pi. And I get that this is about 3.027, or 3.028 if I rounded. Okay. Verifying that with my original, we have log base pi of 32 is 3.027, or 3.028 if you round it. Okay. Okay, one more if you haven't already. Pause the video, give this one a shot on your own. Okay, change of base. Natural log on top, natural log on bottom. Guts on top, original base on bottom. Plugging this in, we have natural log of 512 divided by natural log of 7 is 3.20586. Plugging in my original, we have log base 7 of 512, which is 3.20586. Okay, and so that's change of base. Remember, you don't have to use natural log. You can use log base 10. Log base 10 is really near the natural log button on almost every calculator. So for mine, it's right above the natural log button. It would work as well if you wanted to. If you wanted to, you could change it into some random base, log base 4. But as long as you do the same log base on both top and bottom, and you put your guts on top with your original base on bottom, then change of base will always result in the same value as your original logarithm.